Wi-Fi connection across the campus to support access by students and teachers to online tools and materials, collaborative tools, and efficient sharing among all in the school. Smart goal for consolidation of Wi-Fi and co-create a centralized Wi-Fi network throughout the CB1 and CB2 buildings to enable students and teachers to easily connect to the internet for research, assignment activities, and online interactive learning. 100% Wi-Fi coverage across all classrooms, libraries, and common areas, and with at least 95% of students and teachers satisfied in terms of connectivity and performance. Enterprise-level access points such as Adasoft can be deployed to make sure the school's Wi-Fi network connection is robust and regulated smoothly throughout. Centralized Wi-Fi system for school. Support the school through the adoption of digital transformation by making online resources available, interactive systems, and instant collaboration mechanisms between the students and teachers. Roll out full Wi-Fi with stable connections for all users within a period of not more than 6 months. Methods of implementing centralized Wi-Fi in a school. Planning and review stage needs analysis. This survey or focus group discussion among teachers, students, and administrators will determine how many users there will be, what bandwidth requirements there will be, and some key locations for Wi-Fi access. Site survey. Take an actual site survey of the school to determine where, inside classrooms, libraries, hallways, and other places, the AP should be placed to maximize coverage, strength, and signal. It ought to be the correct sort of Wi-Fi technology like DASCA 5G business plan. The best equipment is selected depending on the budget, user requirements, and scalability. Access points, routers, switches, and antennas. Design and configuration phase. Network design. Develop a comprehensive network design, including access point placement, IP addressing scheme, and connectivity strategy. Bandwidth allocation. Allocate bandwidth as follows. Students in schools: 1 Mbps per student in classrooms and 3 Mbps in libraries for research and assignments. Teachers, administration, and staff: 5 Mbps per device with access unlimited for presentations, programs executions, and communications. Budget summary for centralized WLAN installation. Equipped in costs. Access points, DASCA business plan, Philippine peso 12,000. Cabling and wiring, Ethernet cables, installation, and other hardware, Philippine peso 125,000. Philippine peso 150. Adapasoft estimated cost, Philippine peso 14,000. Philippine peso 28,000. Data cabinet, estimated cost, Philippine peso 44,000. Philippine peso 80,000. Ubuntu, estimated cost, Philippine peso 54,000. Philippine peso 90,000. Software and licensing, network management software and Adapasoft license, Philippine peso 14,000. Philippine peso 28,000. Annual license, installation and configuration costs, network installation services, Philippine peso 25,000. Philippine peso 50,000. Configuration and testing services, Philippine peso 10,000. Philippine peso 20,000. Training costs, user training, Philippine peso 5,000. Philippine peso 10,000. Administrator training, Philippine peso 5,000. Philippine peso 15,000. Contingency and miscellaneous costs, contingency fund, 10% of the total budget, Philippine peso 25,000. Philippine peso 50,000. Miscellaneous expenses, Philippine peso 5,000. Philippine peso 10,000. Adapasoft security. Security policy measures include WPA3 encryption, VLANs, an isolation of the traffic in the network, captive portals for individual logins, installation, stage install access points, position cited APs A, according to the previous site survey, so that they cover the wide area without interference. Network, cabling Ethernet cable install Tenda or Comfast, apps with antennas and connect them through the switches and core structures. Configuration. The devices to be installed are the routers, switch, APs, and central management system. Testing and optimization. Stage first test. Evaluate Wi-Fi strength, coverage, and general performance in the school using Wi-Fi analysis tools to find and rectify known weak spots. Scalability and future-proofing select hardware and software that could scale to accommodate the growth of users and technological advancements. Plan for the adoption of new technologies, for instance, IoT devices and AI-based learning tools. Community engagement.
Expected outcomes and impact. Increased connectivity and access. Outcome: seamless, high-speed internet connectivity for students, teachers, and staff in all areas of the campus, enabling uninterrupted access to digital learning resources. Impact: enhanced learning experiences, equitable access to digital tools, and reduced digital divides. Acquisition and teaching effectiveness. Outcome: teachers gain access to interactive tools, virtual classrooms, and online resources to enhance lesson delivery. Students can complete assignments, quizzes, and collaborative projects using educational platforms like Google Classroom and Microsoft Teams. Impact: increased student engagement and improved classroom management. Streamlining bureaucratic procedures. Outcome: administrative staff can efficiently manage student information, schedules, and communication. Impact: rationalized operations and data-informed decision-making. Collaboration and communication. Outcome: enhanced real-time collaboration between teachers and students, and improved communication with parents. Impact: it brought forward teamwork, peer learning, and efficient information sharing. Increased flexibility in learning. Outcome: hybrid learning models support on-campus and remote access to lessons and materials. Impact: it promotes blended learning and supports independent learning. It enhances network management and security. Outcome: centralized Wi-Fi management ensures robust control over network performance and security. Impact: enhanced security and reduced downtime. Digital transformation support. Outcome: the Wi-Fi system supports cloud-based applications, e-learning tools, and emerging technologies like AR/VR. Impact: future-ready infrastructure and improved digital literacy. Sustainability plan. Regular maintenance and monitoring. Systems are kept at top operating levels by regular inspections, performance checks, and preventive maintenance. It can avoid costly repairs, which often cause system downtime. As such, it can extend the lifespan and reliability of the infrastructure. Software and security updates. All systems are updated with any available vulnerabilities, enhancements to functionality, and compliance with standards of the industry. These help to protect against emerging technologies and continually evolving security threats. Training and capacity building. Continuous training programs should be offered to make staff and users capable of operating, maintaining, and troubleshooting systems with the knowledge and skills necessary. These aggregate organizational resilience, confidence, and preparation of teams for future technological developments. Support and troubleshooting. For users, definite supporting channels by the organization, which can be used when there are direct concerns or operational issues. Quick solving of problems helps minimize downtime with enhancing user satisfaction as well as operation continuity. Quick troubleshooting helps minimize the disruption with enhancing user satisfaction and operation continuity. Upgrades and scalability. Growth and evolution of plans concerning the system, with scalability as an inbuilt design feature that could grow with demand, assimilate new features, and support changed organizational needs and technologies. There would be a comprehensive financial planning that would provide for resource allocation for regular operations, upgrades, emergency funds, and investments towards sustainability-oriented initiatives to facilitate long-term sustainability. Monitor and measure sustainability metrics in operation. Project. References: Canonical LLN Ubuntu, retrieved 11 Dec 2024 from li/ubuntu.com. Ado PySoft. Wi-Fi hotspot management software, retrieved December 11, 2004, apasoft.com. Ubuntu is a trustworthy open-source operating system that has been designed by Canonical LLC. It is on flexibility and scalability, which is the very reason educational institutes opt for the central Wi-Fi solutions. AutoBysoft specializes in Wi-Fi hotspot management that includes bandwidth allocation, user authentication, and remote monitoring features. Together, these technologies provide a strong framework in implementing school networks that are safe and efficient. This allows improved connectivity, supports the transformation process, and creates user-friendliness in keeping the cost-effective nature of this solution scalable with the further